All right, are you ready to review for our test on radicals? So this is chapter 5 in our book, the Envision Algebra 2 curriculum. And so we talked about solving radical equations and graphing radicals and so on and so forth. So we're just going to go through some of these review materials so you feel more comfortable. So this first one says rewrite the expression using a fractional exponent. And the thing I want you to remember is that when we have this radical, something underneath it, we have an exponent, I gotta make that a little thinner, and an index, right? We have an exponent and an index. And when we switch that over into exponential form, we have that same base, and then it has e over I. Remember, it's exponent over index, like E-I-E-I-O. So that's how we're going to switch them back and forth. So this first one, if you notice, this would be 3x squared to the 1/2. Because the entire thing is under the radical, and remember, if we don't see an index, it's automatically a 2. And since that 1/2 applies to both of them, we would write this as 3 to the 1/2 x squared to the 1/2, and remember that means we multiply their exponents. So in the end, we'd end up with 3 to the 1/2 x. All right, the next one would be x to the 1/5, because we have the exponent, which is 1, and the over the index, which is 5. Okay, that one should be pretty easy. All right, so this one is 256x to the 1/4, and remember that 1/4 applies to both of them, so this is 256 to the 1/4 x to the 1/4, and then we need to see if that 256 has a 4th root. So remember, we're just going to do a prime factorization of this. So that's 256 divided by 2 is 128, right? Yeah, don't make me do math this quickly. Okay, 256 divided by, 128. Okay, and that divided by 2 is 64, and that divided by 2 is 32. Let's see, we could do 8 and 4, which is, oh man, this is getting crazy, 4 and 2, and that's 2 and 2, and that's 2 and 2. Okay, so let's go back to our prime factorization, figure out what we have. 256 is 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay, 2 to the 1, 2, 4, 5, 6, 7. So 256 is 2 to the 7th, okay? So we could write this as 2 to the 7th to the 1/4, x to the 1/4. So we could rewrite that as 2 to the 7/4, x to the 1/4. And if we really wanted to, we could write that as 2 times 2 to the 3/4, x to the 1/4. It just depends on what the final product needs to look like, what you're using this for, but that's basically how you can do that. Okay, let's go on to the next one. This one, remember, it's exponent over index, so exponent over index. Okay, so this is x to the 9/3 times y to the 3/3, and we simplify, so that's x cubed over times y. Easy peasy. All right, we're going to simplify these. So we're looking for the 4th root of 16x to the 5th, y to the 3rd. So the easiest way to do this is to write them all as fractional exponents. And the first thing I'm going to do is I'm going to find the prime factorization of 16, because then we can write it all really nice and pretty. So the prime factorization of 16 is 2 times 2 times 2 times 2, right? Because 16 is 4 times 4. So I'm going to rewrite this as 2 to the 4th, x to the 5th, y to the 3rd, to the 1/4. Okay, and that 1/4 applies to everything. So I get 2 to the 4/4, x to the 5/4, y to the 3/4. So that ends up 2x to the 5/4 is x times x to the 1/4, right? And then that's still y to the 3/4. That doesn't simplify anymore. Okay, so then we can go back to radical form. And these don't have fractional exponents, so they stay outside the radical. And then the x does have a fractional exponent of 1, and y would be y cubed. So that would be it. That's one way to do this one. The other way that we could do this one, and I saw a lot of you guys doing this on our test, that's totally fine, is you write this as the fourth root of 2 times 2 times 2 times 2 times x times x times x times x times x times y times y times y. Woo! Okay. And then you take out groups of 4. So you take out this group of 4 and that group of 4. And you end up with 2x, right? Because the fourth root of 2 to the fourth, that's what this is. The fourth root of 2 to the fourth is just 2. And the fourth root of x to the fourth is just x. And inside we still have x, y cubed. So either one of those options works. So now we've got 18x to the third and the square root of that. So the prime factorization of 18 is 9 times 2 and 3 times 3. So again, we can write this as 3 times 3 times 2 times x times x times x. And then we just take out groups of 2. So we can take out a group of 2, we can take out a group of 2. So we end up with a 3 outside, because the square root of 3 times 3 is just 3. We end up with an x outside, and inside we have 2x still, because it's trapped inside there. It can't come outside the radical without a partner, right? To get outside, you have to be able to take the square root of it, and it isn't possible. The other way we could do this is we could rewrite this as 3 squared times 2 times x cubed to the 1/2. So that would be 3 to the 2/2, 2 to the 1/2, x to the 3/2. And then we just simplify that. 3 to the 2/2 is just 3. 2 to the 1/2 is still going to be under a square root, right? X to the 3/2 is x times x to the 1/2. So both of those ways work. Hope I didn't leave myself any room on this one, so we'll go right above it. So this would be 9x to the 6th to the 1/3. And 9 is 3 squared. So that's 3 squared, x to the 6th to the 1/3. So we end up with 3 to the 2/3, x to the 6/3. And that simplifies, that stays. See, the 3 to the 2/3 doesn't simplify anymore. So it's just going to be still under that radical. You're going to have 9 under the radical. But the x to the 6/3 does simplify into x squared. So there you go. All right, the last one we have here is 8x to the 5th. So I'm going to do this the radical way, the way some of you guys like to do it. So this 8 is 2 times 2 times 2 times x times x times x times x times x times y times y times y times y times y. I think I need one more y there. Okay, now we can take out, since this is a square root, we're taking out groups of 2. This is a group of 2, there's 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 a group of 2, and there's a group of 2. So from each group, outside the radical, we end up with a 2, an x, a y, and a y. And inside, we're just left with 2x. So that equals, and you probably can't see that behind my big head, is 2x squared y cubed root 2x. Okay. So now we're going to solve radical equations. So, and the big thing I want to remember here is for even powers, we need to have a plus or minus, and you'll see that here in a minute. So anytime you see just an even exponent, I just want you to think plus or minus, okay? So first things first, we have this one. We're going to get the x all by itself. And remember, when we're solving equations to get things all by itself, we do the distributive property, the order of operations backwards, right? So we get rid of the 2, we divide by 2 before we get rid of the exponent, right? Because if we look at our order of operations, normally we go this way, okay? Normally we start with parentheses and we evaluate, right? But when we're solving equations and we need to get things by themselves, we go this way. So we start by getting rid of any adding and subtracting, then we get rid of any multiplying, dividing, then we get rid of exponents, then we get rid of parentheses or grouping symbols, okay? So the first thing we're going to do is divide by 2. Okay, and when we divide by 2, we get 243 equals x to the 5th. Now we can get rid of our exponents. So we're going to take the 5th root, because the 5th root undoes x to the 5th. The other way you could have written this is we could have raised this to the 1/5 power. Because, you know, 5 times 1/5, that's going to simplify. And so now we have 243 to the 1/5, so we need to figure out if it has a perfect, fifth, and it is 3. I couldn't remember. But we could figure this out by going 243 divided by 3 is 81. That's 9 and 9. That's 3, 3, 3, and 3. So this is 3 times 3 times 3 times 3 times 3. Well, that's 3 to the 5th. So 3 to the 5th to the 1/5 equals just 3. Now, since this is an odd power, our final answer is just 3. Now, the next one is an even power, though, so we need to check that one out and make sure that we remember our plus or minus. So again, we go the order of operations backwards. So we're going to undo any adding and subtracting first. Then we're going to undo multiplying and dividing. Then we're going to undo exponents. Then we're going to undo parentheses. Okay, so the first thing we're going to do is undo that multiplying. So x to the 4th equals, and 144 divided by 9 does not divide evenly. Yeah, it does. Just kidding. That's 16. I was going to say we're just going to take the 4th root. Okay, so 144 divided by 9 is 16. I should have known that because 4 plus 4 is 8 plus 1 is 9. So, of course, it divides by 9. Anyway, now we're going to undo. We're going to undo by taking the 4th root of this, which is just like that. Take the 4th root of that. Okay, so that makes x on the one side. Okay, and the 4th root of 16. See, 16 is 4 times 4, so it's 2 times 2 times 2 times 2. Okay, so the 4th root of 16 is just 2, but since this is an even power, we can have a plus or a minus. And let me explain why that works, because I could put positive 2 in here, and it would come out to 16 times 9 is 144. Or I could put negative 2 in here. If I put negative 2 in here to the 4th, it still comes out positive 16, right? I could multiply that by 9, I'm going to come out with 144. So whenever you have an even power, you need to remember your plus or minus. Okay, the next one, we're going to divide both sides by negative 3. And we get x to the 6th equals 1. Now we take the 6th root of both sides. So we raise both sides to the 1/6. And we get x equals plus or minus 1. Again, because this was an even root, I could put positive 1 in there, and it would be true, or I could put negative 1 in there, and it would also be true. Okay, last one in this section, and probably the last one for this video. We're going to divide both sides by 9, and 225 does divide by 9, because 5 plus 2 is 7 plus 2 is 9. So remember, if the digits add up to 9, then it divides by 9. So 225 divided by 9 is 25. So that's 25 equals x squared. And then we take the square root of both sides. The square root of 25 is plus or minus 5. Since this was a positive root, 5 squared could have been 25, or negative 5 squared could have been 25. All right, so that's it for this video. I'll make another one with the next unit.